All right, these are the notes for the general sequences and finite and infinite. And just a little background knowledge here. Sequence, it's just a list of things that are in order. It's usually numbers. So a sequence is a list of things that are in order. So that's what a sequence is. And usually we use sequences is going to be numbers. Then we have finite and infinite. So right here it says an infinite sequence, braces a sub n, is a function whose domain is a set of positive integers. So first off, infinite just means that it never ends. It continues on forever. So it's a list of numbers that never ends. A sub n, that right there just represents the entire sequence. Okay, so an infinite sequence, which never ends, is a sub n, which represents the entire sequence, is a function whose domain is a set of positive integers. Then it goes on to say the function values or terms of the sequence are represented by here. So a sub 1, a sub 2, a sub 3, a sub 4, dot, 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 all the way to a sub n, which means it just kind of goes on forever. So pretty much a sub 1, a sub 2, a sub 3, a sub 4, you can list that like as values, like the subset 1, 2, 3, 4, that's the position of each one. So like my first term is a sub 1. My second term is a sub 2. My third term is a sub 3, all the way to my nth term is a sub n. So this tells the position and this tells the actual value. So a sequence whose domains consist only of the first n positive integers is called finite sequence, and this pretty much finite right here means that it ends. And a sub n, right here, a sub n is just going to be your general term. So this right here, general term, because you'll see that written quite often here. For example 1, it says writing terms of a sequence from the general term. So write the first 4 terms of the sequence whose nth term or general term is given. So it's asking me to write the first 4 terms. So let's start there. So we have 2 examples. First one here, a sub n equals 3n plus 4. So you'll just see me work them out. So let's start with a sub 1. That's going to be my first term. So we're going to change this n to a 1. So 3 times 1 plus 4. 3 times 1 is 3 plus 4, which is 7. Now we go to a sub 2. So 3 times, instead of n, we now change it to this little subset, which is 2 plus 4. 3 times 2 is 6. 6 plus 4 is 10. So I see 7, I see 10. I'm just going to continue on. A sub 3. 3 times 3 plus 4. 3 times 3 is 9 plus 4, which is 13. And so I'm going to the 4th term. So a sub 4 is going to be my last one here. So 3 times 4 plus 4. 3 times 4 is 12. Plus 4 is 16. And last, I write my answer as a list of numbers in braces. So braces, starting with my small numbers, 7, 10, 13, 16. And this will be my answer right there. All right, on to part B. So part B is this formula here. So same thing, we're just going to do a sub 1. So negative 1 raised to the first power, because I'm changing that n to the n here, which is 1, divided by 3 to the first power. And I always like to put this in parentheses, minus 1. Now I'll just work this out. Negative 1 to the first power is negative 1. 3 to the first power is 3 minus 1. So negative 1 over 3 minus 1 is 2, so that's negative 1/2. Now we do a sub 2. So now the ends are going to change to the subset of 2. So negative 1 squared divided by 3 in parentheses squared minus 1. Negative 1 squared is negative 1 times negative 1, which is positive 1. 3 squared is 9. 9 minus 1 is 8, so we have 1/8. A sub 3. So negative 1 to the third power divided by 3 cubed minus 1. Negative 1 to the third power is negative 1 times negative 1, which is 1, but times another negative 1 goes back to negative 1. 3 cubed is 27. 3 times 3 is 9, times 3 is 27. And last, 27 minus 1 is 26, so we have negative 1 over 26. Last term, the fourth term, is a sub 4. So negative 1 to the fourth power over 3 in parentheses raised to the fourth power minus 1. So negative 1 to the fourth power, if this was negative 1 and we multiply by itself one more time, negative 1 times negative 1 is a positive 1. 3 to the fourth power, 3, 9, 27 times 3 is 81 minus 1. So my last part of this will be 1 over 81 minus 1 is 80. So last we write our answer as a list, starting with my smallest one, negative 1/2, 1/8, negative 1/26, and 1/80th. And these are finite because they do end, they terminate.